hope you all are good. Guys, the topic what we are going to discuss today is about the graph or trigonometric functions. And before we start graph, we need to know a relation that is f of x or y equal to a sine of bx plus c. What these terms a, b, c represents, where a represent the amplitude of the function, b helps to find the period of the function. Period is defined as 2 pi over b. Whatever be the coefficient of x with the sine or cosine function, you need to divide 2 pi with that defines the period, right? And here if I add one more thing, plus d as well. Okay, so c represent, this is translation vector, again translation about x-axis. As it is positive x, it may, the figure will move towards the left side, and if it is negative, you know already we have done this in the functions video, how the transition taken place. All three cases of transformation we have discussed in the previous video. And the d represent the translation about y-axis or vertical axis, right? Plus d represent that the function in the graph will move upward, and if it is negative d, so it will translate to downward. Okay, these are the few basic things which you need to know. And now we are going to start the graph like the first case. And one more thing, the same thing you can do for or f of x is equal to, if it is cosine function, a cos of bx plus c plus d, right? Okay, so first we draw the graph, simple graph, that is function of x is equal to sine of x. And before we start it, we should know about the domain and range. As we know, dome of x is what x belongs to such set of real numbers, and the range of this will be, any range of, and this will be -1 till 1, which means it will fall between -1 and 1. Okay, and how can we plot this? And if you go the period of this, period will be 2 pi over b. And how can we get b? Just we can write it as sine of x plus 0, right? So here the coefficient of x is 1, so we can say the period is 2 pi by 1, that is 2 pi. So now plot it. This is the vertical axis, this comes to the horizontal axis, x-axis, and this is y-axis. As the period is 2, we start from, say, 2, here is 2 pi, this is point of intersection of the axis, that is origin. So if we make half of this 0 and 2 pi, half is pi, that come to be here. Same on the other side, if 2 pi is here, minus 2 pi, half of it is pi, minus pi is here. Then what will be the half of pi and 2 pi? That is 3 pi by 2, and half of 0 and pi is pi by 2. Same you can move on the other side, minus pi by 2. Half of minus 2 pi and minus pi is minus 3 pi by 2. As it is clear, its range is 1 and -1. So I'm going to expand it, say minus 1 is here, right? So it means if I draw a dotted line like this, because this shows that the graph will not cross these dotted lines and it will be lying in between these dotted lines. Let's see now. when we replace x with 0 here, the sign 0 is 0, so 1 comes here. And second one, when is pi by 2, at pi by 2 sine pi by 2 is 1, so it will be here. And sine pi is 0. We can calculate it. You know, pi is equal to 180 degree. Pi is in radian measure. It can be asked in degree as well. So 3 pi by 2 sine is minus 1, so it will be here. 2 pi is 0 again. Same with the other hand, minus pi by 2, it will comes minus 1, and minus pi is 0, and minus 3 pi by 2, it will be plus 1 and 0. So these are the dots. Now we are going to plot it or joining it. You will see the shape like this. This is the curve for f of x is equal to sine of x. We draw this graph over here. I hope it is clear. So this is simple. Even in O levels we have done this. Now let's go for the other case. Once we need to say the second case is about f of x is equal to cos of x. That means cos of 1x plus 0 has to find the period, and it will help us to define it. So here the domain of cos is the same as of sine function, that is set of all real numbers. Range is also same, that is lying between minus 1 and 1. And what will be the period here? Period is 2 pi by b, and b is 1, so 2 pi by 1 means 2 pi is the period of this cosine function. Now we have to plot it. Here I draw this axis, and which we need to plot the graph of y equal to cosine of x. Okay, here as the period is 2 pi, so let's 2 pi be here, 2 pi, and here the origin, half of 0 and 2 pi is pi, so pi is here, and half is pi by 2 is here, is 3 pi by 2. Once you plot it without the graph paper, this is plain paper, you need to be very careful about the space. You need difference, equal spacing between 0 and pi, pi by 2 and pi, and 3 pi by 2 and 2 pi should be the same equal spacing on either sides. Here minus pi by 2, it comes to be minus pi, here minus 3 pi by 2, and here minus 2 pi. Same case when cos is 0, cos 0 is 1, so you will plot it here, you plot it here, and when it is pi by 2, it becomes 0. And it's better to draw these dotted lines to show that your graph will not cross these range values 1 and minus 1. Okay, and pi is minus 1, cos pi is minus 1, so it will be here. 3 pi by 2 is 0, 2 pi is 1 here. Same with pi by 2, it becomes 0, and with minus pi, cos of minus pi is again minus 1, 0, and 2 minus 2 pi is yes, because in even function cos and it doesn't affect if angle goes to be negative. Okay, now you need to join it like this. Okay, we'll get this shape. I hope it is clear, and let's go for the other case. Okay guys, the third case of trigonometric function is about tangent x. We used to write it tan, that is tangent x, and the first domain of this one, domain of tan x and range of x, we need to write this range. Okay, here we know that tan is the ratio of sine x to cosine x, and we know the denominator shouldn't equal to 0, because if it is equal to 0, then it is not defined at that values. So we need to know what values are there to make this denominator 0. Even cos 0 is at pi by 2, 3 pi by 2, 5 pi by 2, and so on. It means odd multiple of, you can see the odd multiple of pi by 2 makes this denominator 0. So at these values the function will not be defined, so we can write the domain as set of real number excluding any minus the odd multiple of pi by 2 where n belongs to integer. Right, this is general format to write a domain of this one, and range definitely 1 or 0 can be infinity, so we write minus infinity till plus infinity. So these are the values. So let's plot it on here. We can say this is our coordinate axis. Yes, one more thing we need to find, that is about period. What is the period of this 2 pi by b is 1 again, so it means 2 pi, or we can write it here like 2 pi. So it's 2 pi here, its origins, the difference between half of 0 and 2 pi is pi, pi is lying here, and half of it is 3 pi by 2 here. Pi by 2 on other hand, suppose minus 2 pi here, half it's minus pi, minus 3 pi by 2, and minus pi by 2, and we don't know the the range is up till minus infinity to plus infinity, so let it be there as this is why. Okay, first of all we need to draw the dotted lines to justifying the undefined values of this function, as is cause odd multiple, as it was the odd multiple. You know here is derivative odd multiples, that of pi by 2 makes it 0 undefined, this function. So I can write like this, these dotted lines at odd, because it means our value will never be approaching touching this line. It can approach but it cannot touch, come closer but will not touch. Let's draw it. Here you can see I draw these dotted lines, because these are dotted lines representing that where the cos function becomes 0, right, and the function will not be defined, because 1 over 0, 1 over 0 means undefined, that's why we put it. Okay, in either case is negative and positive axis. Now at 0, tan 0 is what? Tan 0 is 0. You can put it 0. Okay, take other color, 0 here. Yeah, in pi by 2 we are not sure, and the values between 0 and pi by 2, that values can be drawn like this. It will be much closer, closer, but will not touch this dotted line, right? Let me draw it more accuracy. Yes, very good. And similarly, again with the line values between pi by 2 and 3 pi by 2, at pi by 2 it becomes 0, because sine pi is 0, cos pi is -1, so it is 0 by number is 0, so it will be shaped like this. Again, the values whatever you will place in between these two intervals will be much closer to this infinite line, but will not touch it, right? Similarly here, if I go with this to this, and even you can proceed beyond 2 pi and 3 pi, 5 pi, whatever you want. Here it will be 0 here, so you can see the shape will be like this. Let me draw it clearly. Yeah, very great. And here it will be like this. So this is the shape for the tangent functions graph, and it's an interesting phenomenon that this is as it is, you can see it is going from bottom to top. Yani, if I change the color, yani from bottom here, from bottom, sorry, to top, the curve shows, right? Let me take this one. It comes this and this and this for all cases. It is increasing. You can see this function is said to be increasing function. Then you can see this yellow one, that's represent the graph is from bottom to top, it's always increasing, so we call this as an increasing function as well, right? I hope it is clear. Let's go for the next tangent graph. Here guys, the fourth case is about the graph of cotangent function, that is a reciprocal of tangent. So I can write cosine x over sine x, and here you can see for all values the denominator shouldn't equal to 0, because at that 1 over 0 is undefined, already we know here, so we need to avoid this case. It shouldn't be any undefined. So sine can be defined for all the integral multiple of pi, yani is pi is 0 and 2 pi is 0, 3 pi is 0, and same with the negative side. So it means we need to know this thing, that where the sine function can be negative, so at these values the function will be undefined. So how to write domain and range? First, domain of this function, set of real values excluding any minus integral multiple of pi, where n belongs to the integer values, and range here as it is, range will be minus infinity to plus infinity, right? Okay, let's see how to draw it. Okay guys, here's the x-axis, y-axis, and as the range is still infinity, we need to mark the values where the function will not be defined in integral values. So it means it will be here with the pi, 2 pi, again with minus pi, and minus 2 pi. Okay, fine. Now we need to plot it. Yes, here it will be 0, right? So you will see the difference of graph shape for the two sine tan x and cotangent x. Tangent x, as I told you, is said to be increasing function. Here the cotangent is the reciprocal of that, so it will be decreasing one, and the shape will be look like at 3 pi by 2 it's 0 here, it's 0 here, 0 here, 0 here, right? So we need to see the graph will come from top towards bottom and approaching to the infinite lines, top to, because this you can experience by taking any values between like minus 2 pi and minus pi, and similarly minus pi till 0, or from here, because this will be as broken for the case, because 0 it will be undefined, and so it will not cross this y-axis here this time, so it comes closer and will be like this, down, and this will be the shape what you will experience while going through this cotangent graph. And here this is the graph of tan x was increasing, but here you can see it's coming from top till bottom, so we call this a decreasing function. It's a reciprocal of tangent. You can see this one, I'm going to shading this one. Oops, yes, okay, right? So this is, we call this a decreasing graph of cotangent of x. I hope it is clear. Let's proceed for the fifth case of trigonometric functions. Okay guys, this one time we are going to plot the fifth trigonometric function, that is y or f of x is equal to secant x, and we know secant x is equal to 1 over cos of x. So cos x shouldn't equal to 0 because it comes in denominator, so not equal to 0, and as the same case of the tangent x, tangent x. So we can say the domain is same like that. Dome of this will be set of real number except odd multiple of pi by 2, so n belongs to the integer, and range will be from minus infinity to minus 1, and union 1 to plus infinity. And why it will be, look at, because minus 1 and 1 for this case will not be the part of your graph, and your graph will be above or below of these values. Suppose here we have 1, here we have 0, and here we have minus 1. It means it is clear, sorry, any graph will not lying in between 1 and minus 1. We can take different values to finalize our graphic values, as the period is same as those cos, and that is about, we can say here it is if I take this value from ranging from say is pi by 2, because it should be the it will be 0 at odd multiple of pi by 2, so I will write only odd multiple here, say pi by 2 here, then it will be 3 pi by 2, then it will be 5 pi by 2, and it will be 7 pi by 2, right? Same on other side, minus pi by 2, minus, because these are the values where it will be not defined. So you can take as many as given in the question, or choice is yours. So I can plot this like a dotted line here, sorry, let me make it straight, and here you can see these are the dotted lines representing that the graph will not be defined at it, this value, these values. Yeah, we can plot this like this, dotted lines. Okay, enough. Okay, fine, do this one as well. Here you will see this portion is that I'm going to highlight this one with the yellow. That will not be the part of your graph. Your shape will not come in between this, the yellow portion, right? Okay, once we take different values of meaning cosine between 0, say from 0 and pi by 2, this is not 0 and pi by 2, yani at 0 it will be 1, yeah, here, and again for in between, and here for any value in between it will be either plus 1 or minus 1, right? And it's pi by 2 0, and it means here pi is 3 pi by 2, it means pi is here, pi here, 2 pi, like so on, 3 pi, and so on. Okay, at pi it will be minus 1, so we can put it here, and 2 pi it will be again 1 here and minus 1 here. You can see the shape will be existing like the parabola existing between these two, this one, or alternative graph up and down, the shape will be this parabolic shape here, here, and same if you go with this at minus pi it will be minus 1, so the graph shape will be closer to lying in between these values, and pi will be this. What you need to do to just you can focus the values. One is shape will be like this. This is about the secant of x, right? In the same case you need to keep carrying for the other type of graph, that is the final one, that is about graph f of x equal to cosecant of x, and you know that is the reciprocal of sine of x, and for this case the denominator shouldn't equal to 0, so it is like cotangent of x, so odd multiple pi, 2 pi, 3 pi, and so on, it will be undefined. So dotted line will come this one, so you can plot it by yourself and you better can define the results. It will be just the same type of the graph, but only the dotted line comes to be at pi, 2 pi, and 3 pi, and so on, same with minus side, right? The shape will be like the same because both have the range range. Okay, we can write the range domain as range 1. For this case, domain set of real number minus integral multiple of pi, where n represents integer, and range will be like the same, and from minus infinity till minus 1, union 1 till infinity, and these two values shouldn't be the part of the graph. The same yellow portion as we have done here should be represented by this. This is as a home task. You can draw it by yourself. I hope you understood everything. See you for the next video for the further application of this graph. Goodbye.